Welcome to Naradar Academy. In this video, we are going to discuss about length of plane curves. That is, how to find the length of a plane curve using integration. Okay, this process is called rectification. That is the process of determination of length of arc of plane curve whose equations are known is called what? Rectification. Okay, straight away let me go to the formula. See, I have stated the formula in three different forms. Suppose if the equation of the curve is given in the form of uh, Cartesian form, that is y equal to f of x, then length of the curve from x equal to a to x equal to b is given by integral a to b square root of 1 plus dy by dx the whole square into dx. So this formula is used when it is given in the form y equal to f of x. Sometimes the curves may be given in the form x equal to f of y. In that case, just you change, instead of dy by dx, it will be what? Dx by dy. Okay. Then, suppose if the curve is given in the form of parametric equations, x equal to f of t and y equal to phi of t. In terms of parameters it is given, then the length is equal to integral a to b square root of dx by dt the whole square plus dy by dt the whole square into dt. Right? Suppose if the equation of the curve is given in polar form r equal to f theta, in that case length of the curve is given by integral alpha to beta square root of r square plus dr by d theta the whole square into d theta. So these are the three different formulas for finding the length of plane curves. Okay, now let's see the formula. Let's see the problems in each of the above mentioned formats. Okay, first problem, find the length of the arc of the parabola x square equal to 4ay measured from the vertex to one extremity of latus rectum. Okay, so what is the equation? X square equal to 4ay. So it is upward open parabola with here this is the vertex and focus is here. Okay, here x square equal to 4ay. So this is the latus rectum which is passing through the focus, isn't it? Length of the latus rectum is equal to 4a. So all these things you would have studied in coordinate geometry. So this is the parabola. So we have to find out the length from the vertex. This is the vertex, no? From vertex to one extremity of latus rectum. So this L dash is the latus rectum. From here to one extremity means here. Okay, only this OL. What is the length of OL? That we have to find out. Okay, so we very well know if this is the latus rectum, its coordinates will be what? 2a comma a. From the properties of parabola, we have to determine this. Okay, so the limits will be from where? X equal to 0 to here x is equal to what? 2a, isn't it? So the limits are from 0 to 2a, right? What is the formula for finding the length? Square root of 1 plus dy by dx the whole square, isn't it? So from the given equation of the parabola, we want to find what is dy by dx. Now the equation is given in the form x square equal to 4ay. So rewrite it, y equal to x square by 4a. So dy by dx equal to 1 by 4a into 2x. Right, that is dy by dx equal to x by 2a. So therefore the length of the curve OL is equal to integral 0 to 2a square root of 1 plus x by 2a the whole square into dx. Okay, so simplify this, you will get integral 0 to 2a square root of 4a square. I am taking LCM, 4a square plus x square divided by this 2a the whole square. When you take it out of the square root, it will be simply 2a. And keep this 2a outside the integral sign. So 1 by 2a integral 0 to 2a square root of x square plus 2a the whole square. So you must know integration formula for doing this. So this is like square root of x square plus a square, isn't it? So apply the formula. So 1 by 2a into x into root of x square plus 4a square by 2 plus 2a square into sine h inverse of x by 2a within the limit 0 to 2a. Now when you apply the upper limit, it will be 2a, 2 get cancelled. So a into root of 4a square plus 4a square will be 8a square plus 2a square into sine h inverse of 2a by 2a will be what? 1. When you apply the lower limit, both the terms will become 0. So simplify this. So it will be what? Root 8 will be what? 2 root 2. 2 root 2 a Okay, already this a and this a get cancelled by 2 plus here multiply this 1 by 2a here. So it will be a into sine h inverse of 1. See, we know the formula sine h inverse of x can be written as log of x plus root of 1 plus x square. So if you put it here, it will be a into log of root of 1 plus root 1 plus 1 equal to root 2. So the length of the curve is root 2a plus a into log of 1 plus root 2. Okay, then the next one, find the length of the curve y equal to log of e power x minus 1 by e power x plus 1 from x equal to 1 to 2. So the limits are here itself given. So directly we can find out what is dy by dx and substitute in the formula. So here this is of the form log of a by b, which can be rewritten as log a minus log b. Isn't it? So log of numerator e power x minus 1 minus log of denominator e power x plus 1. So dy by dx will be, what is differentiation of logarithm? 1 by, that is, if you have log x, the differentiation is simply 1 by x. So 1 by e power x minus 1 into, chain rule I am applying. Because here simply x is not there, here it is e power x minus 1, no? So chain rule you have to apply here for differentiation. So 1 by e power x minus 1 into differentiation of this term. What is differentiation of this term? Simply e power x minus, here also differentiation of logarithm is 1 by e power x plus 1 into differentiation of this term is e power x. Why do we do like this? Because here simply it is not x, it is e power x minus 1. So we have to apply what? Chain rule for differentiation. So in both the terms e power x is common, you take it outside and you take LCM. So e power x plus 1 minus e power x plus 1 divided by, if you multiply these two terms, this is like a minus b into a plus b. So it will be what? A square minus b square. So it will be e power 2x minus 1. Okay, now e power x get cancelled. So dy by dx equal to 2 e power x by e power 2x minus 1. So now substitute in the formula. Length equal to integral. Here the limits are given in the question itself. X equal to 1 to 2 square root of 1 plus dy by dx the whole square into dx. So square root of 1 plus 4 e power 2x by e power 2x minus 1 the whole square dx. Now you take LCM and simplify. So if you take LCM, it will be e power 4x plus 1 minus 2 e power 2x. That is, this term, I have expanded in the numerator, but in the denominator I am keeping it as it is. Okay, plus 4 e power 2x. So the denominator, if you take out of the square root, it will be simply 1 by e power 2x minus 1. In the numerator, it will be e power 4x plus, here it will be what? 2 e power 2x plus 1. This is like a square plus 2ab plus b square, isn't it? So which can be written as a plus b the whole square, that is e power 2x plus 1 the whole square. This can also be taken out of the square root. So length is equal to integral 1 to 2 e power 2x plus 1 by e power 2x minus 1. Okay, I want to do integration now. So for that I am trying to find any other simplified form. Okay, the integration can be done in any ways. So one of the ways I am following here is, you take e power x outside from numerator and denominator. It will be what? E power x plus, here no e power x is there, no. So it will be e power minus x. Similarly in the denominator, you take e power 1x outside. So it will be e power 1x minus, since it is not there, it will be e power minus x. So both e power x will get cancelled. So simply integral e power x plus e power minus x by e power x minus e power minus x. Now you look at the numerator and denominator. Differentiation of the denominator will give you the numerator, because differentiation of e power x is e power x. Differentiation of e power minus x is minus e power minus x. It is here. So when you differentiate the denominator, you are getting the numerator. So the integration will be log of the denominator, isn't it? Okay, so log of e power x minus e power minus x within the limits 1 to 2. Now you apply the limit. So it will be what? Log of e power 2 minus e power minus 2 minus log of e power 1 minus e power minus 1. So it's simply, this is like log a minus log b, which can be written as log of e power 2 minus e power minus 2 by e power 1 minus e power minus 1. Okay. Next, to find the whole length of the asteroid. Asteroid is like this, isn't it? X power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. Here this a, no? So it will cut the x-axis at a, x-axis and y-axis at a. So the whole length we have to find. It is a symmetric figure. So instead of finding the whole figure, whole length, it is enough to find length in the first quadrant and multiply it by 4. Okay, for first quadrant the limit will be from 0 to a. Okay, so the limits are from 0 to a, that is clear. I am going to multiply it by 4 to get the entire length. So first we have to rewrite this equation and find out what is dy by dx. So differentiate the equation, given equation as it is. X power 2 by 3. The differentiation is 2 by 3 x power minus 1 by 3 plus y power 2 by 3. The differentiation is 2 by 3 y power minus 1 by 3 into dy by dx equal to 0. Because y is the dependent variable I am taking here. So when you differentiate y, it will you will get dy by dx. So rewrite this. Dy by dx is equal to minus x power minus 1 by 3. Here y power minus 1 by 3 is there, no? When you bring it to the right side, it will be y power plus 1 by 3. So dy by dx equal to minus y by x power 1 by 3. Now substitute in the formula. What is the length formula? Here, since we are finding in the first quadrant and multiplying it by 4, it is 4 times integral 0 to a root of 1 plus dy by dx. Instead of dy by dx, it is y by x power 1 by 3. This whole square means what? 2 by 3 into dx. So simplify this. So x power 2 by 3 plus y power 2 by 3 by x power 2 by 3 dx. See, this is the equation of the asteroid given in the question. So I can equate this is equal to a power 2 by 3. So a power 2 by 3 by x power 2 by 3. So this power 2 and square root will get cancelled. So simply we get a power 1 by 3. In the denominator it will be what? X power 1 by 3. So when you bring that x power 1 by 3 to the numerator, it will be x power minus 1 by 3, and do the integration. It will be simply what? X power 2 by 3 by 2 by 3 within the limit 0 to a. Now you apply the limits. I am getting 6a power 1 by 3 into a power 2 by 3. It's equal to 6a. Okay. Then next one. Find the perimeter of the cardioid r equal to a into 1 minus cos theta. This is given in terms of r and theta, isn't it? So what's the formula for finding the length? Square root of r square plus dr by d theta the whole square. So this is r equal to a into 1 minus cos theta. Already in the previous video, for finding area of plane regions in a sectorial area, in that one I have given all the different equations of cardioid and how will they look like. Okay, if you want, you can go through that video also. So this is cardioid, which is lying on the left side of the graph. Okay, so this is the cardioid. Instead of finding the whole length, I am going to find the length from here to this place. That is only in the upper half portion I am going to find. I am multiplying by 2. So upper half portion means theta varies from 0 to pi. Okay, first quadrant means 0 to pi by 2. First 2 quadrant means 0 to pi, isn't it? So 2 times integral 0 to pi square root of r square plus dr by d theta the whole square d theta. Okay, let's find dr by d theta. So if you differentiate with respect to theta, it will be a into differentiation of 1 is 0. Differentiation of minus cos theta is simply sin theta. So put it here. So 2 into square root is integral 0 to pi square root of a square into 1 minus cos theta the whole square plus a square sin square theta d theta. So this is 1 plus cos square theta minus 2 cos theta plus sin square theta d theta. Cos square theta plus sin square theta will be 1. So 1 plus 1 it will be 2. 2 minus 2 cos theta d theta. Take 2 outside. So the 2 is here. Root of 1 minus cos theta. But 1 minus cos theta is what? 2 sin square theta by 2. So square root of 2 sin square theta by 2. That will be, you take the 2 root 2 here. So it will become 4a integral 0 to pi sin theta by 2 d theta. Okay, for doing integration, I am going to replace theta by 2 by 5. So d theta equal to 2 d phi. Here theta varies from 0 to pi. That implies phi varies from 0 to pi by 2. So L equal to 4a integral 0 to pi by 2 sin phi 2 d phi. So 8a into integration of sin phi is minus cos phi within the limit 0 to pi by 2. When you apply the upper limit, it will be 0. When you apply the lower limit, it will be 1. So 8a. So the length, total length of the cardioid equal to 8a. Okay, then the next one, find the length of the arc of an equiangular spiral. Equiangular spiral means, see, you will be having spiral like this, isn't it? All the angles will be equal. Okay, all the angle of all the that is all the circles will be same, but the radius will be different. For the first one, the radius will be something r1. For the second spiral, it will be r2. For the third spiral, it will be r3. Okay, between r1 and r2 we have to find. So the general formula which I have stated in the first page that I cannot use there because the limits are given in terms of theta, isn't it? So that formula, see this formula I have stated here, no, in terms of r and theta. Here theta varies from alpha to beta. That formula is not applicable here because here theta is constant everywhere, only r is varying. So this is another formula. You combine this formula in the first page itself. So when theta is fixed and r is only varying, the length is given by integral r1 to r2 square root of 1 plus r d theta by dr the whole square into dr. Okay, now r equal to a e power theta cot alpha. Alpha is a constant. So when you differentiate with respect to theta, a e power theta cot alpha into differentiation of this is simply cot alpha. Okay, I am differentiating with respect to theta. Alpha is kept constant. But instead of this a e power theta cot alpha, I can put r. So dr by d theta equal to r cot alpha. So what is d theta by dr? 1 by r cot alpha equal to what 1 by r tan alpha. So r d theta by dr equal to tan alpha. Substitute in this formula. So integral r1 to r2 square root of 1 plus tan square alpha dr. 1 plus tan square theta is secant square theta, isn't it? So that can be taken outside because integration is only with respect to r. So integration of dr is r. When you apply the limits, it will be secant alpha into r2 minus r1. So this will give you length of the equiangular spiral between the radii r1 and r2. Okay, that's all. Thank you.